Hello, welcome to Special Maths Academy. In this video, we'll be looking at solution to the just concluded Special Maths contest. For this problem, we'll look at linear functions. So that's function that takes the form of a linear graph. So let's say mx plus c. So being non-constant means that m is not 0. Okay. Now we have a and b element of real satisfying this set of equations. So we have 4 equations here. So for the first one, that will be f of a minus b. We just use this formula here, so that will be m into a minus b plus c is a. M into a plus c is b. M into b plus c is a plus b minus 1. And m into a plus b plus c is 1. So these are the 4 equations we have. So you can just label them equation 1, 2, 3 and 4. Okay. Alright, so to simplify this, I'm going to focus on this part here majorly, and here we see that we can make MA and MB subjects and use that to simplify this other 2 to get rid of M completely. So let's do that and see what we get. So equation 2. So equation 1 is comparable to equation 2 minus equation 3. So we'll look at equation 1 minus equation 2 plus equation 3. So that term will vanish, and that will just give us C equal to a minus b plus a plus b minus 1. So that will be 2a minus 1. Then similarly for equation 4, that is similar to equation 2 plus equation 3. So look at equation 2 plus equation 3 minus equation 4. So that term will vanish, and then here we get once again that C is equal to b plus a plus b minus 1 minus 1. So this is a plus 2b minus 2. So we have two values of C, they have to be equal. So this means that 2a minus 1 is equal to this, and we get a will be equal to 2b minus 1. So this means we can actually write a in terms of b, and then in turn we can write c in terms of b. So c would be plug that here, c will be equal to 4b minus 3. Okay, so with this now we can go back to equation 2 and equation 3 to figure out what b will have to be. Okay, so let's just work with equation 2 and equation 3. Equation 2 will become ma plus 4b. So a will be using 2b minus 1 here. 2b minus 1 plus 4b minus 3 is equal to b. So that's m into 2b minus 1 will be equal to 3 minus 3b. And then on the other hand, equation 3 will become mb plus 4b minus 3 is a plus b minus 1. So using the value of a here, we get 3b minus 2. Okay. Then we can simplify this to get mb is equal to 1 minus b. So call this equation plus, and let's call this dot. So if you solve this simultaneously, you should be able to get b and m, and then in turn we can get a and c. So from this we see that if we divide, if we multiply equation 2, equation dot by 3, is going to be similar to the right side of equation plus. So if we multiply by 3, get 3 mb is 3 minus 3b. So this means that m 2b minus 1 is equal to 3mb, and we can collect all terms on one side, factorize m out, and we just get minus 1 minus b, 0. So this means that either m is 0 or minus 1 minus b is 0. But we already had that this m is not 0 since the function is not constant, so that means that this is not possible. So must have that b is actually minus 1. And from this we can get m by plugging it into either of plus or dot, so we use dot. So from dot we'll get m into minus 1 is minus 1 minus minus 1, which is 2. So m would be minus 2. And then also from this we have a, which is 2b minus 1, will be minus 3, and c, which is 4b minus 3, will be minus 7. So now we have everything we need. Anyway, we just need m and c majorly to get f of 1. So we have f of 1 is m times 1 plus c, which is m plus c. That would just be minus 2 minus 7, so that's minus 9. Okay, so the correct option here is option E, negative 9. Okay, so that's the end of this one. Hope you enjoyed. So I'll see you in the next one.